This is a News 10 NBC First Alert Weather Special. Tracking your winter starts now.
Good evening and welcome to another winter season here in Rochester. We're going to go back in time and visit historic storms and look ahead to help you prepare for what's to come.
Yeah, in the next 30 minutes, we're going to revisit not one, but actually two back-to-back snowstorms that buried the Rochester region.
And I hope everyone brought their scuba gear because we're going to visit an underwater volcano eruption and what it has done to global weather since.
And we're also going to go in depth on our lack of winter the last few years.
And of course, look ahead to this winter to see if you'll be using your snow blowers more this year.
So a whole lot of topics to get to, but let's first start off what we usually see here in Rochester. To first start off, let's go with our temperatures because we can see some shivering temperatures from time to time, and we can see below zero on average around 6 times here in Rochester. Now, in terms of our white Christmas chances, it's a 50-50 shot to see that, and we usually average about 100 inches of snow with our biggest snowstorms coming usually in February, and everybody knows that month of March. But going locally now, you can see in the Finger Lakes around 70 to 90 inches of snow are expected per year. Up along Lake Ontario, around 90 to 120 inches. And then along Lake Erie, 120 inches or more is possible. And those big differences, that's all thanks to lake effect. Stacey?
Big old lake effect snow. Speaking of big snows, you may remember this one. Now, back in March of 1999, we had not one, but 2 snowstorms back to back. First Alert meteorologist Glenn Johnson takes us back a quarter of a century to the blizzard of 1999.
Hey, we all know how to deal with those big winter storms, but you know, it's a rarity to get a storm that actually shuts down Rochester completely, but that's exactly what we're talking about. This is the blizzard of 1999, March, and you know, this is coming up on the 25th anniversary. Do you remember this one? Snow was coming down at the rate of 2 to 3 inches an hour. We had snow drifts that were pushing 4 to 5 feet. And at least for a period here, we had blizzard conditions. In other words, I think it was about 6 hours that we had blizzard-like conditions. Let me show you what the criteria is for a blizzard. And you're going to see, obviously, it's going to be the winds. They're going to be pushing 35, maybe 40, 45 miles per hour. And on top of that, we're going to have poor visibility. It's going to be less than a quarter of a mile, and it's usually going to be due to the snow. That could be snow coming down out of the sky, or it can be the snow being blown by those strong winds. Now, if we reach those 2 criteria, well, it's got to last at least a period of 3 consecutive hours, and we certainly had that on the beginning of this particular storm system. Now, we love to measure the amount of snowfall. I'm going to take you to the Rochester airport here, and this was the first part of the storm. March 4th, 1999, we had 22.3 inches of snow. Now, we got a little bit of a break on March 5th, and then March 6th, we got hit once again. Almost as hard, 18.4 inches of snow. And keep in mind here, this is very, very difficult to really imagine this amount of snowfall, but we're going to try and do that. And we're going to illustrate this for you, and I want to show you the first part of the storm right here. If we crudely show you how this measures up, this came up to about my knee. That was the first part of the storm where we got 24 inches. The second part of the storm, you know, obviously that's where it really begins to pile up and it becomes very difficult to shovel. At this point, it's reaching my belly button in terms of the amount of snowfall. But let's show you the actual setup, the meteorological setup with this particular storm system. And this was the first part of the storm. This was track number 1. Now, this is the one that came in on March 3rd. We actually had a couple of areas of low pressure moving to the north, and then it really amounted to a blockbuster storm through central and eastern New York. Now, as we mentioned, we got a little bit of a break on the 5th, and then March 6th, this came in from a different direction. This was track number 2. This came in from the west side, just south of the Pennsylvania border, and there's no doubt there was some additional lake effect snow. Now, if you add all of this up, yeah, it is a heck of a lot of snow. We came up with 43 inches of snow just from these 2 weather systems over a very short period of time. And keep in mind here that now lands us on number 3 on the list for all-time March snowstorms. And we had a state of emergency here in Western New York, something that I think a lot of folks are not going to forget anytime soon.
Thanks a lot, Glenn. And of course, if the snow came up to your belly button, it's about up to my neck. So that was one heck of a couple of storms back in March '99. Now, our number one job, of course, keep you safe and help you plan your day, whatever the weather. But it is even more important when snow starts to fly. Now, one way we do this is with our snow tracker. You may have seen this running on the bottom of your TV last winter. We use this to let you know the latest snow forecast specifically for your town anytime you tune into our newscast. Now, our weather can sometimes change, drastically from town to town or even hour to hour. So we break the forecast down for you town by town to show you what you can expect at your house at a specific time of the day during impactful winter storms. You can see the towns, snowfall amounts, timing, and other weather impacts scrolling at the bottom of the screen during newscasts throughout these storms. And these forecasts are updated constantly, so you're always getting the most up-to-date information as the weather and forecast changes.
When is it going to snow at my house? That's what you want to know. Whatever the weather may be, our goal is to give you as much time to plan and prepare and stay safe as possible. Now, coming up, the threat tracker and what the color on our graphics mean. Plus, something you may have heard about but wouldn't think could have an impact on our weather. How a volcanic eruption a few years back may change our winter. Welcome back. You see it in every one of our weathercasts. The threat tracker is our way of highlighting days that you may need to pay a little more attention to days before they happen. When you see green, know that there's no severe or super active weather in store. Sure, expect a little snow, maybe a busy wind, but nothing that'll cause main issues. This is the type of weather that may be a bit of an annoyance, but not problematic, unlike yellow alert days. Right, Glenn?
Yeah, Stacey, you see it at least a handful of times every winter season. It is the yellow alert on our News 10 NBC threat tracker. Now, this is our way of giving you a heads up when the weather that will likely have more of an impact on your day. It can be maybe just 2 inches of snow that falls during the morning commute, or maybe a wintry mix that leaves just enough ice to coat the area roads. Or maybe it's time to get out the snow shovel, but that could alter your weekend weather plans. These are the weather events that have a moderate impact, and then there are those days that, well, we shut down everything. We shut down area schools, travel is treacherous. Those are the red alert days. Right, Rich?
Yeah, if you see red on our threat tracker, it is time to really pay attention to the forecast. We use the red alert for the big deal events, blizzards and ice storms. Now, timing is also very important when dealing with winter weather. If heavy snow, ice, and wind is expected during the morning or evening commute, then a red alert is put in place. This is a high-impact weather event that could be dangerous or even life-threatening, and you need to be on high alert for updates to that forecast.
And we'll update that forecast frequently. What does a volcano that erupted last year have anything to do with our current weather and perhaps our winter? We turn to First Alert meteorologist Alex Bielfeld, who went in depth on the eruption of a volcano in the South Pacific.
Well, greenhouse gases are essential because without them, life would be virtually impossible on Earth. So let's go down to the studio to learn more. Well, the sun emits solar radiation, and during the day, the Earth absorbs that solar radiation or warmth. However, at night, that solar radiation is allowed to escape back into the atmosphere. Now, without greenhouse gases, all of that warmth escapes back into space. However, with greenhouse gases, some of those gases will absorb and re-emit that warmth back towards the Earth, and that's what keeps us warm. Well, the Earth's atmosphere is composed of nitrogen, oxygen, argon, as well as greenhouse gases. Now, of those greenhouse gases, we have water vapor, carbon dioxide, ozone, and methane. Water vapor being the most abundant and the strongest, as that absorbs the most of infrared wavelengths.
This knowledge is important to know because in January of 2022, the Hunga Tunga Hunga Ha'apai volcano erupted and ejected 146 teragrams of water vapor into the stratosphere. This is equivalent to about 10% of the water vapor found in that part of the atmosphere. Typically, volcanoes eject plume and ash, blocking the sun's rays, thus creating a cooling effect. But this massive release of vapor will likely have the opposite effect on our surface temperatures. In 2023, we have had the warmest boreal summer on record for the globe, and we are staring down the barrel of the warmest fall and year on records by a long shot. Something is up. What is causing this big spike? The answer may be the Tonga eruption. According to the Bulletin of American Meteorological Society's September version of the State of the Climate in 2022, it states, quote, "It is estimated that the HTHH eruption increases the likelihood of exceeding an annual mean global surface temperature anomaly of 1.5 degrees Celsius by 7% in the 5 years following the eruption." The same article also states that aerosols from the eruption, including the water vapor, didn't reach the northern hemisphere until the end of 2022. And, quote, "Elevated stratospheric water vapor and aerosol concentrations are expected to affect the surface climate and the tropospheric temperatures in a manner opposite to their stratospheric impacts." It was soon after the eruption where the southern hemisphere's stratosphere saw record low temperatures too.
We have not reached that 1.5 degrees Celsius threshold just yet, but the Tonga eruption has likely played a major role in the warming we've seen around the globe here in 2023. Now, studies are currently being conducted to fully understand the impacts as well as the duration of those impacts, as they could last several years. And if you'd like to learn more on the Tonga eruption, just head to our website, whec.com, and click on this story.
Whew. With the warming likely to continue, warmer winters may also be on the horizon. The million-dollar question is whether that will affect snowfall amounts. That may be something that plays into our winter in the near future. Now, coming up after the break, you've probably noticed our lack of winter over the last few years. First Alert meteorologist Rich Cornelia goes in depth on the numbers to see if this is a trend that may continue. If you're a snow lover like Alex, you probably haven't been too thrilled with our winters lately.
Yeah, no, I didn't use my snowblower at all last season. And, you know, you think of this once, well, maybe it's a fluke. Twice, well, it's really, you could say, a coincidence. 3 times, that's a weather pattern. The First Alert meteorologist Rich Cornelia dives into the numbers to see if there is a break in this low snow weather pattern.
Lots of times when we start to look at winter predictions, we take a look at what has happened recently and then compare that to similar weather historically. Take a look at history as a way to predict the future. Sometimes the past repeats itself. So let's take a look. We have just had 4 years in a row with below normal snowfall, with last winter being a real dud, if you like snow. Now, it may be hard to believe, as most of us tend to think it always snowed more in the past, but we have actually had a few periods with similar snow droughts. But does that mean anything for this year? So let's take a look back. The last time we saw a long stretch of below normal snowfall was in the mid to late 1980s. Now, how one may use that to predict the future is to see what happened the following winter when snowfall went higher. So let's look at the numbers. The winter of 1989-1990 was about 106 inches. Nothing crazy, but it was back above normal. A look at a few more examples. We had a stretch in the 1960s with below normal until it broke in 1965-66 with 103. Again, nothing crazy, but back above normal. Another was in the 1950s. That one ended with a more robust winter in 55-56 with 121.4 inches. So what does that mean for this winter? Probably that we're due to get back on track for snowfall. Now, another tool is to look at the El Nino and La Nina pattern. We have just come off several years of a La Nina pattern globally and have transitioned into an El Nino this winter. Looking at history, when we have seen 3 or more years of La Nina followed by an El Nino, we get the winners of 2002 and 3, 86-87, 1976-77. So let's take a look at how much snow fell for those years. You get 92, 67, and 135. One normal, one way above normal, and one way below normal. It's not a lot of help there. So a lot of this data tells me that we have a pretty good amount of uncertainty heading into this winter. So the deciding factor may be, well, how about a little weather folklore? I saw this guy, this woolly bear caterpillar, back in September, and according to many, when you get more brown than black, that means some milder winter times are ahead. We shall see. Now, looking at all this data, we really don't see a clear picture for the winter. I think it will come down to how the overall storm track sets up, as it could be active from the Gulf to the East Coast. Exactly how that impacts us here in Rochester, yet to be determined. So stay tuned.
TBD. Now, coming up, that winter outlook. We've dodged the big snows here in Rochester lately. What is this winter looking like? Stick around. Welcome back. I know you want to know what our winter is going to be like. Simple question, right? But sometimes we have to take the long road to get there. Sometimes we have unclear directions that we have to muddle through. Sometimes it even takes us around the globe. Like checking out the water in the Pacific Ocean, or seeing what's happening in the Indian Ocean, or the extent of the snowpack in Siberia during the fall. These are all teleconnections and sometimes can help to lead us down the road to our winter. Most winters, we first start off with something you hear about often, El Nino. During an El Nino, warmer than average water tends to pool in the equatorial Pacific, just off of South America. Yes, we're going into an El Nino winter, but what can this mean for us? Well, historically, it tends to bring a less amplified jet stream, which can lead to fewer outbreaks of Arctic air. An El Nino pattern tends to lead to a warmer and drier winter season in the Northeast. But if you're thinking that's a slam dunk for another easy winter, not so fast. Another teleconnection worth examining is called the Indian Ocean Dipole. Simply put, this is the sibling of El Nino, but in the Indian Ocean. There are some indications that a positive IOD with an El Nino like this year could possibly lean toward average or above average snowfall locally. But take this with a grain of salt. This teleconnection hasn't been studied as long as some of the others. Lastly, Siberian snow cover is another phenomenon that can sometimes influence our winters here in western New York. Some meteorologists have discovered a connection between above average snowfall in Siberia in October to a weaker polar vortex, thus leading to more cold outbreaks and snow for the Northeast. All right, so what does all of this mean for our winter? Well, we're getting some mixed messages. We may not be looking at your typical strong El Nino, warmer and drier weather leading to another wimpy winter. These other factors could maybe lead us down to a potentially colder and snowier road than recent winters. Now, the team goes over, we're going to go over the snowfall predictions in just a second, but overall, I'm thinking a more typical Rochester winter, a little more harsh in December and January compared to where we have been as of late, which is, not that hard to do, and perhaps slightly above average snowfall. As a team, we're going around 110 to 120 as far as our snowfall predictions, but we always like to break it down. This is fun. This is our little interdepartmental snowfall contest. Rich, 120.
120, baby.
Pretty good. I'm going 110. Alex and
I go 110 too. I think we have that good chance.
Yeah, we didn't talk about this. Glenn.
I'm going to go 125. We're going to go big this time. And, part of this is that I looked at it. We have an atmosphere that has a memory, and it's a storm pattern that may be similar to what we had in the late summer and the fall, would continue going into the winter season. If that's the case, there could be a lot of snow going up the East Coast, and at the very least, we may get a lot of cold air coming in that could produce some lake effect snow. We'll see how this pans out.
Always a wild card.
I was going to say, to bounce off of what Glenn was talking about, temperature-wise too, in my package we were talking about how the globe has been seeing very warm weather, but this past summer here in Rochester seemed pretty normal. Wasn't that bad.
Yeah, one of the weirdest parts of last winter with the lack of snow was the incredible lack of lake effect. And I think, as Glenn was saying, that more active East Coast storm track could certainly increase our snow here.
Misbehaving El Nino? We'll see you later.